Again, welcome to Biostat 1. And this is our first lectures. And these lectures, we're going to study about measurements, different types of data measurements. First, we're also going to learn about what is a biostat, organization of data, types of measurement, and also data quality. So we know that statistics is not merely a compilation of computational techniques. Statistics also is a way of learning from data, such as data mining, data science. The difference is that in data science, we normally use the big data, a very large volume of data. In statistics, it's not so. So it's also concerned with all the elements of study design. So when I want to do some studies, again, I have to understand my research plan, what type of research. Based on that, I have to have the study design. Is it going to be survey to collect my data, or I'm going to use an experiment to collect the data, or what kind of questionnaire, etc. So when we talk about study design, also data collection, also the analysis of numerical data, and also does require judgment, a lot of judgment. So data analysis, again, is about experience also. So biostatistics is a statistics techniques that are applied to solving biological and also health problems. So what is the definition of biostat then? Here we say it's application of stat principles or techniques to medical, public health, and also biological applications. So collecting, summarizing, interpreting information, and also making inferences that appropriately account for uncertainty. There are some issues and limitations in biostat tasks. First, you will say we always must clearly define our research question. Again, in any research, always the first thing is our plan. The plan and the objective of the research. This is where we can generate our research question. Also, we must choose appropriate study design, the way in which data are collected. Also, we must select a sufficiently large representative sample. And when we say a representative sample, we mean to avoid or remove any bias. Example would be if a politician, let's say a Democrat, trying to pass a bill, and we want to do a survey about it, whether the public support it or not. If we want to collect a sample, most likely we will find a place where we more or less like a swing state, where we have 50-50 Democrat and Republican. But if we go to an area where 90% of the population are Democrat, then we know there will be a bias because everybody will support the bill, since the bill is going to pass by Democrat. So we must also carefully collect and summarize our data. Also quantify uncertainty. And we may discuss all this, especially when we get to inferential statistics. We must also appropriately account for the relationships among characteristics. We must limit inferences to appropriate population. So here we say what biostatisticians does. Here we say they are data detectives because they can uncover patterns and clues in a data set. This will involve exploratory data analysis and also descriptive statistics. They are also data judges who judge and also confirm clues, and this involves stat inferences. So the careers in biostat, again, as a biostat can pursue a career in pharmaceutical industry, government agencies, academia, or health insurance organizations. At present, the demand is far exceed supply of qualified biostats today, according to, again, the Labor Department. Also, we know biostats, or even a statistician, fall under data analysis. So example would be data science, data mining, pattern recognition. They're all using almost the same techniques in solving problems. So the training and also skills that we need is mathematics background is very essential. Biostat knowledge and stat knowledge, very essential. Since this is biostat, again, public health and biology knowledge is very important. Computer skills, again, we have to know some computer applications, such as SPSS or R or some any application. MATLAB is very good. Because nowadays, again, as a stat or biostat, we are going to use a computer to solve the problem. Also, communication skills, analytic skills, organizational skills, attention to details. So now we get to our first topic in biostat, which is the measurement. Here we define a measurement as assigning of numbers and codes according to prior set rules. And we have three broad types of measurement: categorical, ordinal, and quantitative. Now, in some textbook, they will tell us we have four broad types of measurement, which is categorical or nominal. Here we are using the term categorical. Sometimes some books use the term nominal. Ordinal. Instead of quantitative, we have an interval and ratio. Both interval and ratios are values, but in interval, 0 means something, such as temperature. When we say a temperature is 0, it means it's cold. But in ratio, 0 means nothing. So for example, the balance in my bank account is 0, or my height is 0. It means I don't even exist. But here we, again, break it into three types, which is categorical or nominal, then ordinal and quantitative. So categorical means classify observation into a named categories. So we say that categorical or nominal data, we cannot do arithmetic operations. The only arithmetic operations we can do is counting. So example here, HIV status classified as positive or negative. So here we can count how many positive we have, how many negative we have. But we can't say positive plus negative is positive. We cannot add or subtract. So in categorical, the only arithmetic operation we can perform or stat operation we can perform is mode count. And also the ordinal is also category that can be put in a rank order. So example would be a smoking. We have a light smoker, mild smoker, and then heavy smoker. Or stages of cancer can be classified as stage 1, stage 2, stage 3, stage 4. So that's why it's called ordinal. It's in order, the order or ranking. Then quantitative, we say the true numerical values that can be put on number line. So example can be age or your cholesterol level. But now, as I said earlier, some textbook, we break the quantitative into two. We have the interval, which most examples we always use is temperature. When the temperature is 0, it means it's cold. In ratio, I can use example as a balance or blood pressure. If your blood pressure is 0, it means you don't have blood pressure at all, or if your balance is 0 in your bank account, it means you don't have no money. So let's see some example here. Again, here we are dealing with only measurement. So here they say weight change and also the heart disease. This study sought to determine the effect of weight change on coronary heart disease risks. So sometimes we can see there's an association or relationship between weight of a person and maybe his heart risk of maybe having a heart attack or something. So here we say studies of 115,818 women between the age of 30 to 55 years of were free of CHD, which is the coronary heart disease, over 14 years. So here, this is just a sentences. Now we want to know which one will be a categorical, which of the data will be categorical or nominal, and also ordinal or quantitative. So here, measurement included a body mass index at steady entry. So we have a BMI at age 18. Then CHD, which is the coronary heart disease case onset, to be yes or no. So we can see that CHD will be categorical, yes or no. BMI at age 18, so the body mass index value will be quantitative, it's a value. Or when we go here, 115,818 women, it's a value, so that will be quantitative. Between the age 30 to 55 also will be quantitative. Free of CHD over 14 years. The years again quantitative, but the CHD, it depends. We can set it as a qualitative because it can be yes or no. But if we want to measure the heart rate, then that's a value now. It's a value. So that will be again quantitative. So these are some of the categories based on the example we have. So smoker, current, former, no. CHD, onset, yes or no. Family history of CHD will be yes or no. So these are all categorical. Then ordinal can be you're a smoker, non-smoker, light smoker, moderate smoker, or heavy smoker. Still, the ages, as we said earlier, is quantitative, is a value. Body mass index is a value, so it's quantitative. Weight and the weight at age also, they are all quantitative. So next we move to what is a variable, value, and observation. And one thing I would say is that here we are studying statistics, not college algebra. So we know in college algebra, variable means any unknown value. So we represent any unknown value as a variable, maybe X or Y. But in statistics, it's a little bit different. So first, let's go through what is observation. So observation will be the patient or the person. So here we say the unit. The unit upon which measurements are made can be an individual or aggregate. So again, observation is the unit upon which measurements are made and can be an individual or aggregate. A variable, more or less, is the attribute or the characteristics of the observation. So here we say the generic thing we measure. Example, age of a person. So the age will be the variable and the person will be the observation. So sometimes we may use the term the characteristics of a person can be his age, his weight, and these are all variables. Or HIV status of a person. The status is yes or no, HIV is a variable. So a variable will be, again, the characteristics of an observation, or in this case, a person. Value will be what variable has. So let's say the age is 20 years. Age is a variable, 20 is a value. HIV is a variable, yes or no is a value. So we have 4 observations with 5 variables each. How do we know we have 4 observations? Because we have observation 1, 2, 3, 4. They are here. And each observation have 5 variables and 5 values. So the first variable is the first name, last name, gender, age at depth, and primary field of study coded. Now, the values will be for first name is John, last name is Snow, gender is male, age is 45, the code is 1. So again, here we have what we call the observation, which are the patients. The variable are the first name, last name, etc. And the values are what the variable store. So this is an example of a data table. We have again, this observation will be the whole row. So we have age, sex, HIV, onset, and infect. So the variable is age, sex, HIV, onset, infect. Then the values on each variable, here we have 3 observations. So we have 3 different ages, sex, HIV, etc. So that's what we say. Each row corresponds to an observation, and each column contains information on a variable. And each cell, the cells are the boxes, contains a value. So this is an example given to us. This is a per capita cigarette consumption in 1930, and also lung cancer cases per 100,000 in 1950. So here we want to see if there's any relationship between countries that consume more cigarette. Do they have more lung cancer rate per 100,000 population? So if I have this data set, my observations will be the countries. So here we say unit observation, this data are individual regions, not individual people. So individual regions. So the regions will be the country, USA, Great Britain, etc. Values are what is inside in each. And also we have the variables. So variables will be the columns, and observation will be the rows. So observation for each country, for example, USA, 1,320 lung cancer patient per 100,000 population. So observation again is the whole row. Columns, names are the variable, and the data inside each column is called the values. So next we study what is a data quality. In computer science, we have a term saying that garbage in, garbage out. So if you have a bad data, most likely your result also will be a bad result. So an analysis is only as good as its data. Garbage in, again, garbage out. So does a variable measure what it's supposed to? First, we have to do our validation. So validity test, freedom from systematic error, and also objectivity. Here we want to see that things as they are without making it conform to a worldview. So here they say we should consider how the wording of a question can influence validity and also objectivity. And it's very important. So again, in this lecture, this is our first lecture. The main goal we learn here is what is a biostat, what a biostatisticians do, and also the skills you need. And then our first major topics for this course is measurement. So we start with the measurement. As we said earlier, we have 4 different categories in many textbooks, but sometimes we miss. Instead of saying interval ratio, we make all together quantitative because they are all values. So we have the categorical, which is the nominal, normally to be names. The ordinal means some data values that are in order, like first, second, third, or ABC grading. Then we have quantitative, which is a numerical representation of any data or attributes. So we're going to end here and wish everybody the best. The second lecture will be coming soon. Thank you. Bye.